And now we're gonna talk about percentages, and here is an activity to make things clear. In a school, 40% of the students are girls and the rest are boys. Do you see? That's what we mean by a percentage. 40%. It's read like this. 40% of the students are girls and the rest are boys. Do I know the number of girls here or the number of boys? No, I don't know the exact number of girls or boys. All what I know is the percentage of girls and as well as the percentage of boys, because I can find it as well. Determine the percentage of boys and deduce the number of each of girls and boys if the total number of students is 1200. So how to go from percentage into exact numbers? Let's see. First of all, to determine the percentage of boys, it's very easy. All what we have to do is to subtract 100, because 100 represents the total percentage, minus the percentage of girls. So 100 minus 40 is 60%. That tells us that surely the number of boys is more than the number of girls, because the percentage of boys is more than the percentage of girls, but we still don't know the number of each. Now, to find the number of boys or girls, to find the number of girls first, we use the cross multiplication method. We say that in 100, if it is the total, if the total is 100, we have 40 girls. That's what we mean by 40%, means in 100 we have 40. So how many girls do we have in 1200? So here is for the total, and here is for the girls. So for the so if the total is 100, I have 40 girls. What if the total is 1200? I have an unknown number of girls and I need to find it. So I use the cross multiplication method. I multiply 40 by 1200 and we divide always by the number facing the unknown, and the division here is by 100. So I will get 480 girls. Now I know the exact number of girls, so definitely we can know the exact number of boys by subtracting 1200 and 480. So as you see, the number of boys is more than the number of girls, as you see, because the percentage of boys is more than the percentage of girls. Now if you want to use the cross multiplication method, all what you can do is to write in 100 there are 60 boys. So because the percentage is 60%, then how many boys do I have if the total is 1200? And using the cross multiplication method, we can exactly get 720 boys. Now another activity. In a box of balls, among each 250 balls, there are 75 red balls. So it's like a constant relation. Among each 250 balls, there are appearing 75 red balls. It's constant, okay? So because of that, I'm going to find the percentage, or I'm asked to find the percentage of red balls. Here I have the exact number of balls, and I have the total number of balls and the exact number of red balls, and I need to find the percentage of these red balls. The solution here, for each 250, again here is for the total, so here is for the total, and here is for the red balls. So for 250 balls as total, we have 75 balls as red. What is the percentage? Then I should write 100 under the total. I have to represent it by x. Now cross multiplying, I will get 75 times 100 divided by 250, and the percentage is 30%. So I have 30% out of the total that are only red balls. Let's continue about percentages, and we are going to talk about linear relations and percentages. another activity in order to make things clear. In a school, 40% of the students are girls. It's like the previous one, but here we are going to use this example to find a relation, and the rest are boys. Determine the percentage of boys again. Now, part B, suppose that X represents the total number of students and Y represents the number of boys. I need to express Y in terms of X. So let's repeat the question. There are 40% girls and the rest are boys. I need to find the percentage of boys. That's very easy. In part B, I have to suppose that X represents the total number of students and Y represents the number of boys. I need to represent or to express Y in terms of X. Here we go. Percentage of boys is 100 minus percentage of girls. Here I guess there is a mistake. It should be percentage. Printing mistake, no problem. 100 minus 40, it is 60%. Now, the linear relation between X and Y. Again, Y is for the number of boys. X is for the number of total students. Now, the boys, it's very easy. The boys equal the percentage, which is 60%, which is 60 divided by 100x. Then Y represents 0.6 of X. So Y is equal to 0.6x. I will repeat. Y goes for the number of boys, and X goes for the number of students, for the total number of students. I have that the percentage of boys is 60%. 60% means 60 divided by 100. So 60% means 60 divided by 100. 60 divided by 100 out of the total. Because I say that boys are 60% of the total number of students. So that's how to represent this. 60 divided by 100 out of the total number, which is X. Now 60 by 100 is 0.6, and thus Y is equal to 0.6X. That's the relation, a linear relation between Y and X. Here is another activity. A store announces a 20% discount on all of its items. So there is a discount. Determine the percentage of payment after that discount. So if there is a 20% discount, then surely the percentage of payment is going to be 100 minus 20, which is 80%. So I'm going to pay 80% of the initial price of any item. Denote by X the actual or the initial price of any item, and by Y its new price after the discount. Now find a relation between Y and X. Again, I have two unknowns, X and Y. X represents the actual price and Y represents the new price after the discount. Now how to find this relation? So part A, all what I have to do is to find the percentage of payment, which is 100 minus 20, which is 80%, as I told you. Now to find the relation, I have to use this percent, which is 80%, to write Y, which represents the new price, is equal to the percentage I'm going to pay of the initial price. So again, the new price represented by Y means equal the percentage of payment. That's what I care about, the percentage of payment, which is 80%, which means 80 over 100 of means multiplied by the old price of the old price. 80 over 100 is 0.8, and thus Y equals 0.8x is the linear relation I'm searching about.